Hi, my name is Jim Clark, and I'm going to talk to you today about SBOMs and about how Docker image layers can be used to present SBOM data in a new way. So an SBOM is a function of the Docker image content and how it was built. And we're kind of accustomed to thinking about the SBOMs in terms of what packages are in your Docker images, the whole Docker image. But we can also start to think about this as how are the packages distributed across the image layers of your Docker image. And there's some advantages to doing it that way. And so we're going to talk a little bit about that, how we do it and why. So yes, an SBOM is a function of your Docker image, but your Docker image is composed of layers. So you may have a Docker file instruction which produces layer B. You may have a Docker file instruction which produces layer A. You have a from line which produces one or many base layers. And together, the cumulative effect of those layers is to produce an SBOM. But really, the components and the packages that are listed in that SBOM are actually distributed across those layers. And why do we care about that? I think it's useful to think about this in terms of layer ownership. So in a typical like Docker file scenario, maybe we have a Docker file instruction which says copy something from our Docker context into an app folder. And in doing so, it's adding a package, probably at least one. We may have another Docker file instruction which says run npm run CI. And if you've used npm before, you know that probably pulls in a lot of packages into that layer. Another instruction might be a from line. And when we have a from line, we pull in all of the layers from that base image. And that base image itself might have a base image owner who is taking care of how those packages get pulled into that base image for us. And that base image itself might also be based on a base image. And so in this case, the node base image is itself based on Alpine. And the Docker official image maintainer of Alpine is in control of how packages get pulled in there. So yeah, we have a lot of packages pulled in, but some of those packages come from Alpine and maintained by the maintainer of that image. So you may have some packages pulled in by the person who's managing your base image. And then of course you've got your own Docker file instructions inside of the Docker file. So there's different people responsible for how packages overall get into your image. So how does this look? How might we present this data? So this is a very, very early view of how we might present layers and present SBOM data that's in those layers. And so we start off with an instruction, and there's a copy instruction here, and this pulls in one package. And then we have a npm CI Docker file instruction, and this pulls in 322 packages. And we have a Node.js base image, and that pulls in 10 packages. And then we have Alpine, which pulls in 18 packages. So we have a little bit of an understanding here. It's actually the second layer, npm CI, which is pulling in the most packages. It's also one that we sort of control. We can drill in and look at, well, what is my base image here responsible for, and look at those individual packages. We can kind of jump over to the Docker file representation and see what that looks like. Our ability even to jump across to another Docker file. This is the Docker file from our actual base image, showing where we pulled Alpine from. So we can do some interesting, we can present the data in a kind of an interesting way here. You get to see a little bit of a breakdown as to how these packages are being produced and who owns them. Now, there's actually some things about this that are kind of hard to do. So one of them is tracking the content. So on the left, we see what sort of like a more raw view of what an image is. It's a set of layers, and we have some sort of like content addressable ID for them. They're digest. They're a bunch of blobs. We would like to see the picture on the right. We'd like to see who's responsible for the layer. And sometimes we've got that metadata. I mean, often we've got that metadata depending on our build tools. So we can see that one of the layers is produced by the copy instruction. Another layer is produced by the run npm run CI instruction. When it comes to the from lines, it actually gets a bit murkier. We can really lose track. It's very easy to lose track of what tag was used to produce these particular digests. So there's 6 layers here which are pulled in by this one particular tagged image, this one particular digest of an image. But if we don't have that recorded in the image, how do we reconstruct that? Well, what we've done here is, one, we've looked at all the public content that we've built a reverse index where every time we see a certain set of layer blobs, we go, oh, I recognize these came from Alpine. Oh, I recognize these came from node base. So it allows us to look at an image, and even if we can't reconstruct the Docker file completely, we can at least look into this index and go, oh, I recognize this. I know where this comes from, and this is this particular base image that you pulled it from. So we're kind of able to build this view on the right. And when you jump back over here, you see like it's really important for us to be able to see how these from lines nest. And so we really care if we're waiting for a package to be updated in Alpine, and then waiting for our Node.js base image person to pull that in as well. Like it helps us understand how these updates, these packages are getting to us. So a lot of this is about shared content. So at the bottom of this, we've got this Alpine image, and has these two blob digests, and it's always going to have those 2 blob digests. And maybe Dockerfile A and Dockerfile B both produce images that use those. And in some sense, I mean, they're both contain content driven by the SBOM of this base image. It's not always true that the cumulative effects of adding layers doesn't like change packages. I mean, that's an additional complication. But the underlying SBOM that we record here is useful in the context of looking at all the different images which share these same base images, and a lot of content does share this, and it's a lot of public data as well. This is we're building these indexes, and we're tracking these SBOMs across Docker official images, all of the images coming from Docker verified publisher, from the DSOS program, from DistroList, from Bitnami, from the Microsoft Container Registry. By indexing all of this and making sure we have SBOMs for them, we're getting like a public data set ready that we can use to build nicer views of this kind. So what we're doing here is we're watching for all these images getting pushed into registries, and we're extracting this data and indexing and making it available. But we're also paving the way. Even though we're doing this extraction when the image is pushed, we're paving the way for us to be able to record this data when it starts to arrive at build time as well. And I'll say a little bit more about that. So why are we doing it? Well, verification for sure, and supply chain security is a real thing. When you look at these images here, when you look at the base images, like it's notable that sometimes we can say, hey, you're based on this base image, it produces 18 packages, and these come from the Docker official image program. So these are the processes that were used to produce this content. And over time, we imagine being able to give more information about why do you trust that the packages that we're listing here are actually the ones that are in that. And some of these have to do with trusting certain signed attestations. Some of them just are about being aware that this program is producing images in a safe way, and you're benefiting from that. So for sure, like verification and supply chain security issues are important. We also want to look at targeting advice. Like we want to look at how we learn new things about all of the open source that we pull into our images. So on the left of this picture, we see the idea of advisories. And in the background, these advisories are constantly changing. New ones are coming in, existing ones are being updated. There are all sorts of public sources of these vulnerabilities that I've listed here. We have tools from our partners like Sneak, who are producing data that is going to help you understand the risks you're taking in your images. These sources of advisories are it's background work that's constantly churning away that we want to take advantage of. And really, I think we should think about this as sort of like a separate ongoing process. On the right side, we have our images, and I kind of on purpose sort of drew this almost like it looks like a virus or something like that. But what the point I really want to make is that an image with its SBOM is the packages in the SBOM are a kind of a way that the image says, hey, I'm interested in a particular kind of advice, or maybe we think of it as advice binding only to images that have certain packages. Of course, this is how we index images in a way that we make sure that advice gets targeted. And I think it's also really, really important to understand that because images are the things that we use to produce runtime containers, and runtime containers are the things that are in our environments. If we are able to track our images in our environments, we're able to target advisories directly at those runtime environments. And that can help us focus our reaction to new information. So I want to just highlight the example of, like, say we do get a new advisory. And so we know what that advisory is, or that set of advisories that have just been created or updated. And here's like the next 4 lines here are a little bit of kind of like logic programming for you. But the set of advisories that has just changed is related to a certain set of packages. And all of the images that contain that package is another set that you can look at. And some of those images will have containers that are running, and some of those containers will be running in environments that you care about. And so with a little bit of extra data here, we can take the data from the SBOMs, which help us correlate images to packages, and we can sort of target advisories all the way down to runtime environments. So as long as we trust the facts that are coming out of our SBOMs, we can shift some of our analysis towards actually targeting runtimes. And the last point I made here is about internal advisories, which I think is really interesting, because there's nothing about what we've said so far that says that it has to be an advisory like an external vulnerability or something like that. I mean, if the developer has some advice about some internal library and they're trying to target that advice to a particular set of consumers, it's actually a really good way of doing it. Being able to just pop up and say, I want everyone who uses this internal library versions this to know and so we can look at this mechanism of helping get information to the right people as an example of using SBOMs more effectively. So let's go back to our view here and think a little bit more about this package centric look at this. So yeah, we see all the packages that are here, but those packages are sort of a substrate for us to look at like other kinds of new information that comes in. If I take a look at all of the vulnerable information that I know about right now, which is of course like in the millions of these little snippets of information, and I switch to this and see, okay, well, if I switch to using this to overlaying vulnerabilities on here, I see some other interesting things. Like there's this one package in here which has a vulnerability, and interestingly, I seem to be on version 14.19, and there's a fix in 14.20. So that's kind of interesting. I can also see that there are 4 potential fixes here in the Alpine image, and I can take a look at what those are. And so we overlay some of this advice on top of our SBOM data, but we also do it in such a way that we can look at, well, I really am looking to probably update this base image. There seem to be some important reasons to do so, and jumping into my NPM packages, I seem to have all kinds of fixed buys here. I probably need to do an NPM update, and that's my problem. That's something that's right there in my image. I think it's also useful to think about SBOMs in the context of, like, often we're using them in our delivery when we're saying, okay, I have a candidate image, I know it's SBOM, I know what's going into it, and I want to make an evaluation about this image. But at the present time, we seem to have a bit of amnesia about the SBOMs that we've already deployed. And that's kind of a shame, because if we keep track of these SBOMs, they actually provide a very good context for us to reduce noise. So the delta between the SBOM of a candidate image and the SBOM of a deployed image can really help us to put into context new advisories. So it's an example of, let's just say that we just learned something new. We've got 2 new advisories, A and B. If we forget all about our deployed images, we might just look at this as this candidate image shouldn't go. But in fact, the deployed image, it has these advisories these advisories are relevant to it as well. And so it would be, it's not preventing anything by continuing to let change go here. And it would be crazy if we fixed one of these advisories, say we fix advisory B and held this back just because it still had advisory A, when if we were to deploy it, we would actually remove a real problem from our deployment. And this happens all the time, because we forget that the SBOM is something that we should continually use. Like it's a new source of information that we can use to evaluate our changes along the way. So nobody wants to be assigned work by a bot. That's for sure. And when this becomes really noticeable when developers complain about the noise of this. And I mean, I've sat with developers and looked at some of the tools that we try to sort of present naively. And if the noise is too much, the cure just does feel a little bit worse than the disease. But at the same time, I think people understand that there's a real beneficial effect of staying up to date, because we understand that we are in a larger community than just the teams we're working on, where we've got maintainers in Docker official images who are busy working on getting changes out. We've got bug fixes coming in from the open source that we pull. I mean, our team is like a special kind of remote, but there's all this work going on that we can also benefit from. And keeping track of how our SBOMs can allow us to map to those work streams, and allows us to sort of think about taking advantage of them in new ways. We know software is a maintenance activity, but who is doing the maintaining? So we might be responsible for some of these layers at the top of this image, but we've also got people in our team working on getting rid of vulnerabilities from some of our base images, or our Docker official image maintainers working on pulling together great collections of packages that we can use here. So there's we are part of these extended teams, which is a great thing for us to be able to take advantage of. So here's an example where I've got a PR, and it's the same. It's on the same repo that I was demonstrating earlier in this view, and our Docker file is using Alpine 3.14, and we always use digests inside of our Docker files to make sure our builds are reproducible. And here we've recognized that the maintainer of the image has produced a new one, and so we've opened a PR, pulled that in, run it through our CI, do all that in the background. But then we can pop up and oops, sorry. Then we pop up, sorry, and make another message, which I put at the bottom here. And we look at this and say, hey, this actually removes 6 vulnerabilities. And so that extra bit of context helps you to see, if CI passed, if all your tests have passed here. We noticed that out there someone made this change, and it is meaningful. If you were to update this, we would be able to remove 6 vulnerabilities for you. So we can kind of like help put this in context so that we can wade through the noise a little bit more effectively. So I just want to leave you with a couple of summaries about this. We are tracking these SBOMs in a lot of the public content, and we're looking at the public content that people are really using in their base images. So we're trying to get this data out there. So the question is really, how do we put this to work for us? How do we most effectively put this data to work? And a couple of the examples I've given here are, well, targeting. Let's keep track. Let's use this SBOM data to help us get the right advice to people based on what they're actually using. And also filtering. I mean, noises, we're really obsessed with this idea of trying to use as much as we can, as much data as we can, to kind of like filter that noise. And that goes all the way to things like layers. Like we think it's relevant if an advisory is on a Docker file line that maybe that you wrote. And so if we see, like this line right here could use some work, well, that's something that's important, and we want to like delineate that. So again, this is just a sample of ways that we're thinking about taking this data and presenting it to developers in a way that we hope is going to be really useful. So thank you very much for your attention, and I will talk to you next time.